All right, in section 5.3, we're going to be talking about solving trig equations. So a couple of reminders as we get started here. First reminder is when we're solving a trig equation, remember what we're trying to do is find the angle x, that when we take the sine of it, we get an answer of 1/2. And so another way of showing that is doing our inverse trig. And that, again, would tell us what angle that if we took the sine of it, we would get an answer of 1/2. And this is where you would have to go back to your hand trick. Go back to your right triangles, or we'll take a second real quick here and go back and do a reminder of memorizing quadrant 1. So if you memorize quadrant 1 or like to use this for the inverse trig part of it, we will be speaking exclusively in radians. So a reminder that the first angle would be a pi over 6, that our next angle would be a pi over 4, and our last angle would be a pi over 3. And the ordered pairs that go with each of those would be our square root of 3 over 2 comma 1/2, square root of 2 over 2 comma square root of 2 over 2, and this last one would be 1/2 comma square root of 3 over 2. And that with each of those ordered pairs, remember it is alphabetical order, so that would be cosine comma sine. So that's just a reminder of memorizing quadrant 1, or you can go back to your hand trick, whatever it is that you did to do the inverse trig, which was section 4.6, would be the same idea here. Also, some other reminders, we will be talking about where are our trig values positive or negative. Now, different than doing inverse trig, we're solving equations, and so we actually will solve on the interval they give us, which will be 0 to 2 pi, which means we could be eligible for all 4 quadrants. And so think through your all students take calc to think about where functions are positive and negative, and make sure that you're answering from each of those quadrants. And then we'll remind ourselves of what those angles are in each of those quadrants. And so if we were talking about a pi over 6 reference angle, in quadrant 1, pi over 6 is just pi over 6. In quadrant 2, the pi over 6 angle that would put us into quadrant 2 would be 5 pi over 6. The pi over 6 that would put us into quadrant 3 would be 7 pi over 6. And the pi over 6 that would put us into quadrant 4 would be 11 pi over 6. Same thing with our pi over 4s. First quadrant would be pi over 4. Second quadrant, 3 pi over 4. Third quadrant, 5 pi over 4, and fourth quadrant would be 7 pi over 4. And our pi over 3s that put us into each quadrant, pi over 3 would be in first quadrant, 2 pi over 3 would put us into the second quadrant, 4 pi over 3 would put us into the third quadrant, and 5 pi over 3 would put us into the fourth quadrant. Generically speaking, obviously, it's just going to be over your denominator, pi over the denominator in quadrant 1. In quadrant 2, it's always going to be, and this is just kind of generically speaking, your numerator is going to be 1 less than your denominator. In quadrant 3, your numerator is going to be 1 more than your denominator. And in the fourth quadrant, it's always going to be 1 less than 2 times the denominator, or double the denominator. That's just generically speaking, and that works for all of our over 3, over 4, over 6s. All right, so getting into actually solving here, remember that we're going to use the rules of algebra. They still all apply, even if we're doing trig. So I could look at this equation if I were to think in rules of algebra. Instead of writing it as a sine x, write it as like a variable. And think about how you would solve the equation 2a minus 1. Reverse order of operations to get that a by itself. It's the same idea with our trig functions, is that we're trying to get this sine of x by itself using our correct or reverse order of operations. So our first job on this would be to add 1 to both sides, divide by 2, and we get to the sine of x equals 1/2. Now that means we've got a positive sine value, so we think through our all students take calc. and sine would be positive in quadrants 1 and quadrants 2. So as I get my answer here, I'll have an answer from quadrant 1 and I'll have an answer from quadrant 2. So the angles that would give us a sine value of 1/2, this is where I'm going to go to my hand trick or go to my memorizing quadrant 1 or my special right triangles, whatever method I use at this point. But the angle that gives me a sine value of 1/2 would be an angle of pi over 6. And pi over 6 would be the pi over 6 in quadrant 1. And the pi over 6 that would put us into quadrant 2 is going to be 1 less than our numerator. So 5 pi over 6. What you're going to notice as we work through today is that we're going to have a varying number of answers, and as we go to our next video you'll see an even more variation in our number of answers. And guys, you can have answers anywhere from no solution all the way up to, I think the most we usually see is 6, maybe 8 on a really complex problem, but we don't usually get that many, but I would say somewhere in the 2, 3, 4 range is very, very common. Okay, so then how do we deal with a reciprocal function? A secant, a cosecant, or a cotangent? And I would treat any of those three the same way that I'm about to do this problem, is that I would solve for the trig function just like I did on the last page, but we would have one more step before we answer what angle we're talking about. So again, if I just get that secant by itself, I would add that to both sides and get that the secant of x equals 2. And then at this step, once I have it by itself, is I'm going to reciprocal both sides. Now that looks a little different depending if you're talking the left-hand side or the right-hand side. On the left-hand side, the reciprocal is exactly what we think. Flipping 2 over 1 becomes 1 over 2. On the right-hand side, or on the left-hand side, reciprocaling secant, remember our identities here, is that secant of x equals 1 over cosine. So its reciprocal then would just be cosine of x, and we can do that for any of those three. So the reciprocal of secant being cosine. I've now turned both of those fractions upside down. Doing this a longer route here, if we wanted to show this as a longer route, I could replace secant with 1 over cosine of x equals 2 over 1, and then you can see that we're really just turning both sides of that fraction upside down to get cosine x equals 1/2. So again, now we would think through our all students take calc. Cosine is positive in quadrant 1. Cosine is also positive in quadrant 4. So as we find our angles x, we will find those angles from quadrant 1 and quadrant 4. And the angle that gives us a cosine value of 1/2 would be pi over 3. And pi over 3 in quadrant 1 is pi over 3. The pi over 3 that puts us into quadrant 4 is always 1 less than double the denominator, so 5 pi over 3. So anytime we're going to have a reciprocal in our function, come back to this idea, solve for it, and then you have to do this step right here. Do the reciprocal of both sides, and then continue on like normal. Okay, what if we have trig functions on both sides of our equation? If we have trig functions on both sides of our equation, again, think algebra. If I had something like 5a equals 3a plus the square root of 3, just replacing those cosines with a. Again, I would get my like terms, which would be 5a and 3a, to be on the same side of the equation. So I'd probably subtract 3a from both sides. And we're going to do the same thing, but it says cosine instead of a. So I would subtract 3 cosine of x from both sides of the equation. 5 minus 3 is 2. Continue to get that cosine then by itself. Once it's by itself, I consult my all students take calc and highlight for myself where cosine is positive. Cosine is positive in quadrant 1. Cosine is positive in quadrant 4. So we'll have answers from quadrant 1, and we'll have answers from quadrant 4. Now down here, this part where I'm putting quadrant 1 and quadrant 4, that is just completely to help me make sure that I put answers from the correct quadrant so I don't forget a quadrant or forget an answer. That is not necessary to like highlight which one is from which quadrant. It's just for my my note-taking purposes. So again, finding the angle that gives me then a cosine value of square root of 3 over 2, that would be a pi over 6, and pi over 6 in quadrant 1 is pi over 6. The pi over 6 that would put us into quadrant 4 would be 11 pi over 6. All right, how do we deal with it, our equation when we have something that is squared? And we'll see this happen a lot. Again, we'd solve for that function to start with, so we're going to divide by 2 here. We get sine squared x equals 1/2. And again, if I kind of come over here to the side and say, okay, think about what this was. If it wasn't a sine function, it would say a squared equals 1/2, and we would undo that by square rooting. We're going to do the same thing. Get sine by itself by square rooting. Now, 2 very important things need to happen when I do that. And the first of those things is when I square root, I need to put the plus or minus on my answer. I'm also going to think of this one as the square root of 1 over the square root of 2. Remember that we would not leave a radical in the bottom, so we're going to rationalize. And we're looking at the square root of 2 over 2. So, as we think through our all students take calc, we have both the positive and the negative version of this one. So sine is positive in quadrants 1 and 2. The negative part of it means that it's also from quadrants 3 and 4. And so what happens is we get answers from all 4 quadrants. And again, I'm going to put those down here so that I don't forget to put answers from all 4 quadrants here. And then I go back to, okay, what angle gives me a sine value of square root of 2 over 2? And that would be a pi over 4. The pi over 4 that puts me into quadrant 2 would be 3 pi over 4. The pi over 4 that puts me into quadrant 3 would be 5 pi over 4. And into quadrant 4 would be 7 pi over 4. So you can see now, and this is going to happen when it is one of those squared ones, because we will get a plus or minus on our problem, is that we're going to get more answers because we get them from all 4 quadrants when we include the positives and the negatives. Okay, so let's see that in action one more time here. Same type of problem here. Let's get that tangent squared by itself by using our reverse order of operations. Okay, and now I'm square rooting, and again, the key things when I square root is immediately put that plus or minus so I don't forget. If it requires rationalizing, which this one, if I break it into the top and bottom separately, definitely would. Square root of 3. Sometimes it'll simplify down, but this one does not, so I would rationalize. Square root of 3 over 3. Although I do think it's almost easier to think of tangent in the unsimplified version, especially if you're a hand trick person, but this would be a square root of 3, square root of 1 over square root of 3 on my hand, or simplified square root of 3 over 3. Again, because it is the plus or minus in our all students take calc, positive quadrants would be 1 and 3, negative quadrants would be 2 and 4, meaning we get answers from all 4 quadrants. And the angle that gives us a tangent value of square root of 3 over 3 would be a pi over 6. So running our pi over 6 through all 4 quadrants, we'd have pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. All right, just a reminder that we do have some restrictions here. Thinking about sine of x equaling 2 is that if we are talking sine or cosine, the range, which means the answers, which would be this side of the equation, can only go from -1 to 1. And so if we're looking at trying to find an angle that gives us a sine value that is outside of that -1 to 1 range, then that one has no solution. There is no angle, no x, that would do that for us. So it is possible to have 0 solutions. And so again, we're starting to see kind of our range of possible answers here, anywhere from no answers up to, today we saw as many as 4 answers. I do want to point out that there is a second way of asking this question. We are going to do this second set of directions, find all solutions to each equation, and yours are always going to ask you to do this on the interval from 0 to 2 pi. Notice that 0 is included and 2 pi is not. So if you ever want to say 2 pi, you would answer 0. And so let's look at the example here. Tangent of x equals 1. We're going to answer the second one first because that's how we've been approaching these problems, is just one trip around our unit circle. It is a positive number, so if we think about all students take Calc, tangent is positive in quadrant 1 and quadrant 3, so we'd have an answer from quadrant 1, we'd have an answer from quadrant 3, and this is always one of those tricky ones, that tangent of x equaling 1. Remember, that comes from a pi over 4 angle. And the pi over 4 angle in quadrant 1 is pi over 4. The pi over 4 angle that puts us into quadrant 3 would be 5 pi over 4. And like I said, this is how we are going to answer all of our questions. So I want you to keep an eye on this part of it, because that's what we're going to do. It's from 0 to 2 pi. However, I do want to show you up here the solve each equation for all values of x, because this is actually how I have seen or heard it have been presented on like an entrance exam to a university when you get your math placement, things like that. So how do I transition these angles to all values is basically we include those coterminal answers, or adding or subtracting as many full circles to the primary answer of pi over 4 and 5 pi over 4. So to show that, our first one would be pi over 4 plus as many full circles, in radians full circles being 2 pi, n, and the n just means as many full circles, positive or negative direction, as we want. And those would be all angles that would be coterminal to pi over 4. 5 pi over 4, same thing, plus as many full circles in either direction, so 2 pi n, and that would be all angles associated with that value. There's one last thing I want to leave you with here before we go, is just a reminder that they can also fall on an axis. So this would be times when we have a question like, when is the sine of x equal to 1, or when is the cosine of x equal to 0? Things like that would put us on an axis. So let's do a real quick review of what our axis angles look like. In radians, that would be 0, pi over 2, pi, 3 pi over 2. And what are the ordered pairs that put us on those axes is really what we need to think through. So that first one would be 1, 0, at pi over 2, 0, 1. At pi would be -1, 0, and 3 pi over 2 would be 0, -1. Remembering that each of those ordered pairs is alphabetical order, so cosine, sine. We can also land on an axis if we were looking at something like a tangent of 0. Remember, would also put us on an axis, and again the answer is what angle would put us on that axis. And just a quick reminder that if you ever wanted to answer 2 pi, you would actually answer 0. They are the same angle, but this one is not included in the directions that say from 0 to 2 pi. So again, anytime you want to say 2 pi, you're going to answer 0 instead. All right, and your assignment over this is the 5.3 worksheet A.